Alright guys, this is a second lesson in the trig unit. This time it's on trig ratio, and okay, let's get started then. So consider an angle in standard position. Let's say something like this. The point P with the coordinate x and y is on the terminal arm. So let's say you have a point here. Whatever this is, who cares? Coordinate x and y. So if you're using the technique that I showed you on the last lesson, how to figure out the reference angle, then you would do this. Starting from here, not there, because you'll see in a second we are trying to make a right angle triangle. Okay, and of course this would give you angle theta. Okay, what else can you label here? So if the point P has a coordinate of x and y, so that means x, the width, is x unit, y, the height is y unit high. And then if we call the length from here to this point P R, then I hope you can see that we have a right angle triangle, and we can take advantage of Pythagoras theorem or Pythagorean theorem. I don't know what you learned from junior high, but anyway, so the distance from the origin to point P can be found by using Pythagorean theorem. If you don't want to call that R, you can call it whatever you want. Okay, so now let's apply this. A squared plus B squared equals to C squared. So let's write this out. So that means the square of this, which is in this case x, and then square that, plus the b square. You can call this a and then call this b, doesn't matter. And then in this case I call that a, I call this b then. So b square, which is y square, equals to c square, except that I don't have a c, instead I have r and then square. So this is Pythagorean, Pythagoras theorem. Okay, using the concepts of a reference triangle, we talked about that from last day. If you don't remember that, you can go back to last day's lesson. And then SOHCAHTOA. Before I move on, I want to quickly refer you to your formula sheet. The SOHCAHTOA from Math 10C, they are here. Oh man, sorry. So SOHCAHTOA. I'll briefly talk. You don't have to memorize this. If you're wondering why I use R for the length of the hypotenuse, because I'm just following the notation here, right? So let's quickly talk about. So check. So let's quickly talk about which one is which. So if you look at this here, the side opposite to the angle, you call that opposite. And then the side right next to that, not the longest one, adjacent. And then the side that is the longest, we call that hypotenuse. Alright, so have a look. I'm not going to go back to this, because as long as you know which side is which, you can just plug the numbers in. Opposite, adjacent, hypotenuse, something like that. Okay, so this is the same thing you see on the formula sheet. You can fill this in. I'm not going to repeat myself. And if you're still having problem with the SOHCAHTOA stuff, you can just look at the Math 10C stuff from last year. Alright, so let's keep going. As long as we have the values for x, y, and r, this is the length of the hypotenuse, the longer side, we can find the trig ratio for any angles in center position. Okay, so how we get these three values depends on the situation. So I'll just briefly go over the notes, then after this we'll work out examples and it will make more sense. So first one here, we will need to find trig ratio when if the question is asking, if the question gave you a point on the terminal arm, so on and so forth, and then ask you to do something, definitely the trig ratio. So it may give you something like, oh, there is a point of 4 and -3 on the terminal arm, blah blah blah. Then when you see something like this, you know that's the time you should be using the trig ratio, whichever applicable, either sine, cosine, tangent. And the second scenario is you are given a specific ratio and the quadrant the arm is in, so you may be given something like, let's say sine theta is -2/3, and then you are told that it is in quadrant 4, something like that. Okay, then that's the time you should be using the SOHCAHTOA stuff, the trig ratio. Last scenario, when you are given a specific angle. So if you're given something like, oh, angle theta is 220 degrees, blah blah blah, blah blah blah, then you know that's the time you should be using a trig ratio as well. Alright, so let's apply the concept. Draw an angle in standard position with point P on the terminal arm, then find the exact value of the trig ratio for each angle. So exact values, that means you don't give me a rounded decimal. So don't give me something like 0.33333, write down 1/3 instead, 1/3. Okay, so now let's sketch this one here. We have a point on, well, at 3 and 4. So sketch this. So 3 units to the right, 4 units up, something like this. If you want, you can draw a line longer and then say something like, oh, the point is here, point P, 3 and 4. Well, that's one way, and if not, it's okay. Here's another way to draw that. So I'll just make a note here. This is point P right here at the tip. And if you draw a vertical line downward, it forms a right angle triangle, and of course this gives you angle theta. Now let's fill in the other information. What does it tell you about the width and height? 3 and 4, 3 and 4. Alright, so if you want, you can use the same notation. What's the length here? You can call that R to keep it consistent with our formula sheet. Alright, so now first thing, let's find out the length of R here so that we can apply the SOHCAHTOA, because we need to know the opposite, adjacent, and hypotenuse. Alright, so let's apply the Pythagorean theorem. So 3 square plus 4 square gives you R square. If I were you, I would use a bracket, because I know some of you have terrible handwriting. Nothing personal. Okay, so if you write 3 square like this, then when you turn around, you may tend to think that it is 32. So don't do that. So now let's solve this. 3 square gives you 9 plus 4 square gives you 16, and R square is still R square. Now add them up, 9 and 16 gives you 25, equals to R square, and then R is 5. Okay, some of you may say, Chen, you just took the square root. Why didn't you put down plus and minus 5 in the last unit? Yes, we have to put down plus and minus 5 when we're doing computing the square. However, I mean computing the square for quadratic equations. Here, if you look at the context, 5 makes sense, but then does negative 5 make sense? No. Okay, you cannot have a length of with a negative number, negative sign. Okay, so now all we have to do is for the trig ratio, SOHCAHTOA, sine, cosine, tangent, sine theta, cos theta, tan theta. These are the three trig ratios you will have talked about. So you can refer to your formula sheet. I'll just refer to it here one last time. Okay, so if you look at this, if you're not sure which one is which, since this is our first example, let me just help you a little bit. So this is opposite, this is adjacent, this is hypotenuse. Okay, so if you look at the formula sheet, for sin, opposite over adjacent, which is opposite is 4, adjacent is 3, so that means 4 over 3. Sorry, I messed up. Okay, so let's do this again. My apology. So sin, opposite, which is 4, and then hypotenuse, which is 5. If you want, we can jot down equals 5. Okay, and then cos is adjacent over hypotenuse. Adjacent is 3. Hypotenuse is 5. So 3 for 5. And then tangent is opposite over adjacent. I mean, if you want to look at the x and y, you go ahead. Okay, so opposite over adjacent. So opposite is 4. Adjacent is 3. Here we go. Okay, so let's keep going. Let's do B here. I'm not going to do all the questions. Anyway, so let's do another one. -8 and 15, same thing. Let's sketch this first. -8 and 15, so up here, quadrant 2. That's your angle theta. You can stop here if you want. I'll just call that P, -8 and 15. Make it a right angle triangle. So now a right angle triangle. And if you look at this, -8 and then 15. So that means this is R. So just like the last question, let's figure out R first by using the Pythagorean theorem. So doesn't matter which one you look at. 15 square, square of this plus square of this gives you square of this, plus -8 square equals to R square. So (15 square gives you 225, and then -8 square gives you 64, gives you R square, and then 225 plus 64 gives you 289 equals to R square. And lucky us, it is a perfect square. of 17. So if you take the square root of that, r is 17. 17. So I'm not going to label which one is which. Opposite, adjacent, hypotenuse. So same thing, we are going to find the three trig ratios. So let's do SOHCAHTOA, sine theta, cosine theta, tangent theta. Okay. So sin is opposite over hypotenuse. Opposite is 15. Hypotenuse is 17. Cos adjacent, which is -8. Be careful, make sure you keep track of all the signs. Over hypotenuse, which is 17. There's nothing we can simplify, we can leave it like this. And then tangent, 10, opposite over adjacent. You can put this one, you can put a negative up front, put negative here, doesn't matter. This one, same thing, negative here, up front, on the bottom, same thing. Alright, so next one, I'll skip D, but I'll still show you D in a second. So next one, you'll see in a second why I want to do another one. You'll probably think, Cheng, I got it. Well, wait until after this one. So again, let's sketch this. -5 and -6. -5, -6. So down here. And again, I'm going to take this endpoint here as point P. You can pick any point here, but to make it look like a triangle, I'll just pick the endpoint here to make it easier, more obvious. So P is -5 and -6. And again, same thing. And angle theta is here. And the width here is 5 units to the right, sorry, to the left, so -5. And then the height here is 6 units down, so -6. Now same thing, your hypotenuse is R, we will find that, so let's put down the equal sign. So same thing, A squared plus B squared gives you C squared. Alright, so -5 square plus -6 square equals to R square. And then -5 square gives you 25, -6 square gives you 36, which gives you R square, and then add up 25 and 36, that gives you 61, which is equal to R square. And then you take the square root of that, so that means R, in this case, unfortunately, 61 is not the perfect square of any integers, so we have to leave that as square root of 61. Okay, so if you look at this, leave as radical form, no decimal approximations. I said that trillions already, and if the ratio can simplify them. That's not an option, you have to do that. So that means in this case, our hypotenuse is square root of 61. So now same thing, let's do sine, sin here, cos, and then 10. So for sin, it is opposite over hypotenuse. So -6 over root 61. When you work out, well, I mean, at this point, this is a perfect answer. It's just the exact value, you have the correct sign, but then when you guys work out maybe questions from textbook or some other questions from the internet or elsewhere, you may see that this is not the answer they have. Why? Because they may have rationalized the denominator. So I hope this is a review for you. So how do you rationalize the denominator? Multiply the top and the bottom by the same thing. So this is definitely a perfect acceptable answer. So just in case, if some of you don't see the answer that you get, then you can do this. So if you look at this, square root of 61 times square root of 61, that gives you 61, and then the top you have negative 6 times root 61. Except if the question asks or say something like, oh, rationalize the denominator. Otherwise, if I were you, I would just leave it like this. Don't do like this. But in case if in the future your answer is not the same as what they have, that means two things: either you screw up or they may have rationalized the denominator. So then you know that this option is available. Okay, so next let's do cos adjacent over hypotenuse. This time I'm not going to rationalize the denominator, I'll just leave it like this. If you want to try, you can rationalize the denominator. Last one, 10 opposite over adjacent. The negative signs cancel out, so that gives you 6/5, 6 over 5. I'm not going to do D. You can check out the answer that I posted as a PDF file. Before I move on to the next page, I want you guys to look at the 3 examples that we work out here: question A, question B, question C. This is quadrant 1. Look at the sign of the SOHCAHTOA if the angle is in quadrant 1. This is in quadrant 2. Look at the sign of the SOHCAHTOA. This is quadrant 3. Look at the sign of the SOHCAHTOA. Obviously this would be in quadrant 4, like this. So 8 and negative 2, 8 and negative 2, something like this. And then this is your angle theta. I'm not going to finish that. Look at the notes that I posted in other folder in the PDF format. Okay, so this is quadrant 4. Once you figure out all this, have a look at the sign of the SOHCAHTOA. Hopefully you figure out something, or you see a pattern. Okay, now next page. Notice the relationship between the signs of the trig ratios and the quadrant theta is found in. So if you look at this, so of course we have 4 different quadrants that we can talk about. We did 3 of them. You figure out the 4th one. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this part, we already mentioned this last day, so I'll quickly go over that. If it is quadrant 1, so let me just sketch this here. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if you look at this, quadrant 1 is less than 90 degrees, but greater than 0 degrees. Quadrant 2 is less than 180 degrees, but greater than 90 degrees. Quadrant 3 is less than 270 degrees, but greater than 180 degrees. Last but not the least, quadrant 4, it is less than 360 degrees and greater than 270 degrees. Have a look. So if you look at this, now I hope by looking at the examples you figure out there is something interesting. So which trig ratio or ratios would be positive in quadrant 1? All of them. Which trig ratio or ratios would be positive in quadrant 2? Only sine. What about in quadrant 3? You should see that it's only tangent that is positive in quadrant 3, and for quadrant 4, cosine. Okay, so if all trig ratios are positive in quadrant 1, so that means negative ratio there is none. Okay, if sine is positive in quadrant 2, that means cos and tan, cosine and tangent, they are negative. Here, if tangent is positive in quadrant 3, that means sine and cosine are negative. Last one here, if cosine is positive in quadrant 4, that means sine and tangent, they are negative. So if you look at this, there is quite a bit of information. You don't have to focus on everything. You might want to focus on this, because if you figure out this one, which one is positive, then you know what will be negative. So now if you look at this, I would like you guys to do this. What do you see? ASTC? No. You see CAS. CAST. I know you will say it doesn't make sense. Let's do it this way. If we look at which one's positive, which one's negative, let's do this. Quadrant 1, everything is positive. Or quadrant 2, only sine is positive. Quadrant 3, only tangent is positive. Quadrant 4, cosine is positive. So if you look at this, CAST, CAS. So this is called the CAS rule. So we can write down here, CAST, CAS. All is positive, or everything. Sine is positive, tangent is positive, cosine is positive. Okay, everything else is negative here. Everything else is negative except tangent. Everything is negative except cosine. So what's the big deal about knowing the CAS rule? Well, you will find this very handy for the rest of this unit. Do you have to memorize that? Nope, but you may have to do what we just did to derive those things. So if I were you, I'll definitely remember this CAS rule. Like this. CAS. Okay, let's put that into use. Example 2, determine if the following ratios are positive or negative. You don't have to tell me the exact value. Okay, so just tell me sine 300 degrees, is that going to give you a positive answer or negative answer? If you have memorized the CAS rule, well, let me just quickly write down here. CAST. So if you look at this, 300 degrees, 90, 180, 270, 300. So that means here only cos is positive, cosine is positive, and you have sine. So therefore, you are going to get a negative number or negative answer. Okay, you can cheat a little bit. If you're saying, Cheng, that's too much to remember, you can use your graphing calculator. And now, just a sincere reminder that radian mole will screw you up. So you go to math. Sorry, not math, mole. Go to mole, down here. Up. For this, nope, down here, my bad. Not radian, go to degree. Enter. Then you can clear this. Now, if you want, from this point on, or as long as you are in this unit, make sure your calculator is always in degree mode, not radian mode. So sine 300 degrees. So sine 300, close bracket, enter. So that gives you a negative number. We don't care what this number is. We just know that it's going to be a negative number. Okay, so next, tangent 245 degrees, tangent 245, 90, 180, 270. So it's going to be here. Quadrant 3, tangent is positive. So that means we are going to end up with a positive number. We will look at that specific number in the next class. Okay, cosine 120, 90, 180. So it's here. Quadrant 2, only sine is positive, and everything else would be negative. So that means this is going to give you a negative answer. Okay, last question. Here we go. Given that cos theta is -3/4 and theta lies in quadrant 3, find the exact values for sine theta and tangent theta. Alright, so I'll give you guys, well, you might want to pause for a few seconds and try to set up a question. And in this case, we're talking about cos, sin, and tan, so definitely look at the SOHCAHTOA. Right, so the first thing we want to do is, of course, to sketch this. You may or may not need to sketch this, but you have nothing to lose. So if you look at this, what is cos? Cos is adjacent over hypotenuse. So adjacent over hypotenuse. So if you look at this, this is my adjacent, this is my hypotenuse. Now there is a problem. Where does you apply the negative? Because you can apply it this way. You can say it is -3 and 4. -3 and 4. It will be up here. Or you can look at it this way. 3 and -4. 3 and -4. Now is it, which quadrant is it in? Sorry, I screwed up here. Let's go back here. So there are two ways you can look at this. You can look at this as -3 and 4. -3 and 4 up here, or 3 and -4. My apology, I don't know what I'm thinking, but anyway, let's go back here one last time. So if you look at this, when you draw two triangles, when you draw a triangle, you have different possibilities. You can have one here like this, one here like this, one here like this, one here like this. So when you say adjacent, so that means this part here. Does the negative apply to 3 or does the negative apply to 4? What does that mean? That means you can either have the adjacent to be 3, so that means you're moving it here, or it is going to be -3, that means you're moving it here. Okay, we can have two possibilities, but if you look at the question, we already know that it is going to be in quadrant 3. So that means we can draw a triangle like this. Quadrant 3. Alright, same thing. This is angle theta. And if you look at this here, so that means our adjacent, opposite, adjacent, hypotenuse. Your adjacent is 3. Is it 3 or -3? Like what I mentioned before. Because it is on the right hand side, going this way, therefore it is negative. And your hypotenuse is this one. Well, of course, if you use your common sense, we cannot have a negative length here for this one. You can have negative x and y value, but you cannot have a negative length here. So that means this is 4. Now, what is the length of this side, so that we can figure out sin and tan? Let's do the math. Again, a squared plus b squared gives you c squared. So this one, if you want, you can call that y. Okay, so now negative 3 squared plus y squared gives you 4 squared. Simple math. 9 plus y squared equals to 16. Y squared equals to minus 9 on each side. That would give you 7. And when you take the square root of that, you don't have to put down plus minus, because you can always have one number here, because you cannot have a negative length. But hold on a second, root 7. Okay, so now if you look at this, so that means my y, this one here, is 7. Square root of that. But remember what I just said, for the x and y values, it could be negative, it could be negative. For negative x here, it can be negative y. For the coordinate, I don't mean the length. The length here is root 7, but in terms of the coordinate, negative 3, this one would be negative 7. Okay, keep in mind, don't get mixed up. The length here, what's the length? The length here is 3. But if you want the coordinate here, what's the coordinate of this point? Negative 3, negative root 7. Okay, now we have everything we need. We can finish the rest. So let's do sin here. I should have been showing you this, but anyway, have a quick look. Okay, sine theta opposite, which is square negative root 7, hypotenuse, which is 4. Done. Again, doesn't matter where you put the negative sign, the top, the bottom, in front, they're the same. Last thing, tangent opposite, negative root 7, and then adjacent, negative 3. The negative cancel out, so that gives you root 7 over 3. Okay, so last thing, assignment, have a look. Okay, try as many as you can.